Cedric, you know what? I see your screen.
All right, nice.
All
And if
right.
you don't,
So
please tell
without
me.
any further ado, Cedric, take over and teach us about Kubernetes and the data gateway pattern.
All right. Okay. Thank you very much. Okay. Yeah. So thank you very much for welcoming me at the AJUG, my first time at the Atlanta JUG. Always a pleasure to meet new folks. So I'm Cedric Lunven, and I'm the director of developer advocacy at DataStax. So DataStax is the company behind the NoSQL database Cassandra. So expect to have words on Cassandra tonight. And I will explain the journey of DataStax to move Cassandra in Kubernetes and what we had to build to make that happen. But that's my day job. At night and during weekend, I'm an open source committer. I created 8 years ago a library called FFRJ, feature flipping for Java, who enable you to do a feature toggle, enable or disable part of your application at runtime, and do a lot more like monitoring features, property, configuration management. And I implemented the same data model in 20 different databases. So I do have some quite experience with databases. And I also use quite a lot of Spring, and I contribute to the Pet Clinic project at some point. This is my Twitter handle. And without further ado, let's dig into the content for tonight. So first, going back, I promise, no selling, no marketing here, all technical. But I need to introduce you what is Cassandra, because based on the capability of the database, you will see why we decide to move to Kubernetes. So put the DB in Kubernetes, and then what's the blocking? What's the issue? So what about the data gateway? What it does, what it solves? And then let's play demo and have demo effect with the APIs and the SDK on top of the SPI, on top of the API, and I will close with resources. Okay. So let's move on. Apache Cassandra is a NoSQL distributed database. It has been created in 2008, so already 13 years ago. You can install Cassandra on a single node with about a capacity of 2 to 4 terabytes and a throughput about 3 to 5,000 transactions per second and per core. But it's a distributed database, so you want to install Cassandra on multiple nodes. In this architecture, there is no master. It's masterless, peer-to-peer. Each node communicates to each other with a protocol called gossiping. And we group nodes in something that we call rings or data centers. I will call rings just for simplicity and just avoid any confusion with infrastructures. So this is a ring. All right. And this is a benchmark, and we know that we can make a benchmark tell anything, but here just look at the trend. The more capacity you need, the more throughput you need, you simply add new node in Cassandra. And this is one of the only databases that can scale linearly, and I will give you some reference in the end. Okay, so this is a ring, just a simple ring, and I want to insert data in Cassandra. In Cassandra, you will store tables, okay? So, but even just a simple table with 20 rows, well, will be distributed around your ring. So select star from your table in Cassandra is not a good idea. You are doing what we call a full scan cluster. And data model in Cassandra is challenging. It's all about denormalization. And this is a trade-off to keep fast response time with petabyte of data online. Okay, data is distributed and data is replicated. You do have your ring. Each node is in charge of a subset of keys in your table. What we do is we hash what we call the partition key, which is kind of a group by. You will get an integer called a token, and each node is in charge of a range of tokens. So this is what I've represented here. So the top here, label 0, will hold the token from 0 to 16.
We're not, the slides do not seem to be advancing. We see Apache Cassandra equals NoSQL distributed database, and we see the node. I don't think we're advancing slides.
Yes, I keep moving my C. So let me stop sharing, start sharing again. Sometimes it does that. What about now?
Black screen now. Sorry.
Oh, that's Zoom. Okay, let me try again if I can do something about that. So let's see. Boom, boom, boom. Advance. And if not, I will come back. So let's start sharing again.
Okay, it says it started sharing screen. I see
Tell me.
no image though, still black.
Okay. So it starts moving and it's not moving anymore. That's weird. Okay, let me try something. I'm coming back. Sorry for that.
No worries.
Did you jinx yourself? You were talking about black screens, right?
Well, that's what he said. So we're trying to see if we can make this thing work.
In the meantime, maybe we could discuss what people think about the whole Foojay project. And
okay, can you make me a host again?
I can certainly do that. I'm going to make you a co-host.
Good.
And I will
you are now a co-host.
Okay, let's do share my screen. Do not
Okay.
go full screen.
Yep,
Yes,
we see.
we're
Yep,
back.
we do. We're
Yep.
good.
Okay, so I won't go full screen. Let's go like that. Anyway, okay, so data is replicated. So not only a node. Okay, let me show you maybe back in 1 minute. Okay, so you see the slide. This is the slide about linear scalability. This is just a regular table, and data is distributed among the node using the partition key. Okay, so far so good. This is the partition key that we will use to create the token. Each node is in charge of a range of tokens. Now the data is replicated, so every single data will be stored multiple times on multiple nodes, and the parameter to do that, it's called the replication factor, RF. So recommended is 3, so any data is stored 3 times in 3 different nodes. That's what we call replica. So what will happen when you do have a new data to come? You will hash the partition key, get the token. You can contact any of the node, and the node will push the data to the replica. You have 3 replica. And now the data is on the replica. Moving forward, if one node goes down, and this is a okay, still not moving. No, I'm back. Okay. All right. If one node goes down, well, because there is no master and the data is replicated, there is no downtime. The system is still available, and when the node goes back online, replica will stream to this guy what it has missed, and so it's a self-healing database. Okay, right? That's another criteria of the DB. In Cassandra, you can have one and also multiple rings inside the same Cassandra cluster. So having a ring per geographic region or ring per cloud, if you wish. It's an Apache 2 license, so no risk to change the license anytime soon. So we know with the actuality that some tools change license just today. And this is a way to have a single technology data layer available across multi-cloud. No selling, it's not magic. You still need to do VPC peering among your cloud. To come to the last slide, and this is the last slide on Cassandra, is why would you use Cassandra? Okay, so I told you about scalability. Add throughput. If you need throughput or capacity, add new node. So here, simply put, this is why you heard about Cassandra for every read, every write. And so use case, event streaming, Internet of Things, log analytics. Cassandra is also used for high availability. There is no master and data is replicated. You can lose any of the node. You can contact any of the node to do your queries, read and write. So plenty of use case. Here I put caching, market data, pricing. It's distributed. I keep saying it's distributed. Okay. So not only having data close to the customer is pretty good in terms of latencies, and this is why the GAFAM are using Cassandra heavily, because they do have customers all across the world. But also for regulation law, I'm based in Paris. It's also 1 a.m. to me. And sometimes we like to have our data center in France due to the law, GDPR. You need your data to be there. So a lot of use case for that. Finally, cloud native, and I will exactly go back to this cloud native. What it means. Okay, so just reference, we like to share Netflix and Apple just to see the range of scale. So Apache Cassandra at Apple, 160K nodes. Not in the single cluster. There is one cluster with more than 1,000 nodes, but still, and 100 petabytes of online data. OLTP, okay, and several millions of per second. Okay, that's the range of scalability for Cassandra. And so our mission at DataStax was to embrace the future. We need to put that in Kubernetes, because this is where people want to deploy anything now. It's the OS of the futures. So first you can see, I will put Cassandra in containers. Boom, the Docker image is there for a long time. I can put my Docker Compose, put my rings, and I'm happy. Well, not really, because the Docker Compose is not dynamic at all. What if you need to scale up? There is a rule at the Cassandra level stating that you need to wait 2 minutes between 2 node insertion on a cluster. And the reason is when a node joins, there is a streaming phase where this node needs to get the data. This is called bootstrapping, streaming the data to the node for the node to be ready. And so Docker Compose has no orchestration whatsoever. So of course, just that is not enough. So we will move to Kubernetes, which is the orchestrator, right? And Cassandra fits in Kubernetes because at core, the database is AP. So, CAP theorem, consistency, availability, partition tolerance. On a distributed system, you cannot ensure the 3 at the same time. You need to pick 2. And depending on the distributed system you are using, some have choose CP, other AP, Cassandra pick AP. You can lose a node, not a big deal. Masterless, data is replicated, share nothing, self-healing, and horizontal scalability. All those capabilities I just explained you at the Cassandra level fit the Kubernetes world, because Kubernetes is all about popping some instance, some pod with multiple containers inside. But Kubernetes control plane can reorchestrate, can move a pod to one part to another, change the IP, or stop a node, restart on another worker. It's at the orchestrator level, and you can easily lose a node, and with the system focus on AP, it's not a big deal. By the way, this is one of the reasons it's not that easy to run some RDBMS system on Kubernetes, because Kubernetes is a distributed system by design. So CAP theorem applies. And so now those guys that were ACID transaction and doing everything pretty at ease on a single machine, now with the distributed, they need to pick. So either they go on cloud ready using only VM, or tweak Kubernetes just to avoid using the pod in the natural way and stick the IP, stick everything just to find what they used to have. Okay. But even then, having a database in Kubernetes is not that easy again. Kubernetes for stateless, super easy. Create some pods, image, deployment, stateful replica set, you're good. You expect your microservice to be there 3 times on your deployment and replica set. If one microservice goes down, not a big deal. Kubernetes will detect, restart, and you get the expected state, you're good to go. What about the stateful? If the node goes down, what about the data? What about the disk? What do you do? Kubernetes provides some stateful set resources, but in the stateful set, the disk, also called persistence volume, is ephemeral. So if you lose the node, the disk could be deleted as well by default. So when you need to deploy a stateful system in Kubernetes, you need to tweak all this stateful set, add some rules. And speaking of rules, the default resources in Kubernetes are not enough. You need to add intelligence. You need to add rules, how to handle different kind of events based on the system. To do so, you are using what we call an operator in Kubernetes. And most systems does have an operator now, including the most famous like Grafana, Prometheus, monitoring tools. Most of them have the operator. So the operator is the guy that will listen events coming from Cassandra, pod, and resources. And based on what's happening, will execute some command to retrieve the expected state. Exactly like Kubernetes control plane, but with custom rules and custom treatment and custom code. And so if you have never heard about operator, this is exactly what it is. Just extending the default resources of Kubernetes and applying new code and new rules. And with the operator, you interact with custom resources called CRD, so custom resource definition. Okay, so far so good. So with that, with the perfect operator, we can run Cassandra in Kubernetes. So at DataStax, we created something called the Cass operator. It's open source. It's a WAR multiple operator available for Cassandra, and it's still, you know how it is. We're still struggling to know who will win the race, but Cass operator is in good shape. Okay. And so with that, we say, oh, let's build a software as a service or managed service Cassandra in the cloud and offer Cassandra to everybody just with that. And guess what? Just having that is far from enough to run a database in Kubernetes. And so on top of running the database, you need to have all the administration tasks, tool, monitoring, backup, and also how to interact with the DB. But I will go back exactly to that pretty soon. And so to cope with all this complexity, on top of this Cass operator, we have creating what we call the Helm chart, which is a recipe, a huge YAML, explaining how to not only set up Cassandra and operator, but also all the open source tooling needed to administrate Cassandra. So it can be metrics collection with Prometheus Grafana. It can be administration task with Reaper and Medusa, and backup restore with Man.io. Okay. Everything provided as a Helm chart, and it's free and it's open source. So just Helm start install Cassandra, cassandra.io, and you can run your own full stack to run the database in Kubernetes. Okay, so now we are happy, right? Not only we can run the database, but also we can do the repair and monitoring and administration task. Yeah, right. What about accessing the data now? If you are outside of the Kubernetes cluster, because you don't want to have your application running in the same probably namespace or cluster as your application, you want to be outside. And so you need to expose some port just to be able to invoke that, and using what we call an ingress, which is a kind of service in the Kubernetes world. And here you see just one implementation of ingress called traffic. Well, as a client, when I connect to Cassandra, because in the Cassandra world, there are multiple nodes, the clients need to connect and open a connection to every single node. And at the driver level, you need to do that to be able to do load balancing and retrying and else check for your DB at any time. And when you need to go through traffic and egress, that's pretty hard to do. And to say the least, okay, there are some advanced way called SNI just to route a request on the single TCP, but it's pretty hard. And this is where a data gateway or some kind of proxy on top of the database make all its sense, okay? So just some screenshot, but I still want to keep moving. Okay, so what about this data gateway? Okay, so if I told you as a developer, okay, start with why. As a developer, do you like to learn new query language? SQL, CQL for Cassandra, N1QL for Couch, GQL, Gremlin, Cypher for Graph database, JSON, Bison for Mongo, whatever. No, what you want to do is just working with object, save my object, get by my object. If it's JSON, it's even better, especially if I work on JavaScript. And this is why ORM or OM, if it's not relational database, and Spring Data are so popular now. You simply want to map your tables to objects, and you're good, right? Right. How do you care how your data is stored? Again, not really. You don't care about the physical data model. You really simply want to save your object, get back. And do you like installing and running database locally? No, you don't. You, as a developer, if you do the integration test, you probably use Docker and Docker Compose, but it's unlikely that you move up to Kubernetes on your local desktop. That's possible. And what about distributed database? Now you really need to ask your boss for a pretty powerful machine just to run a couple of queries. So not good. On the other side, if you are in charge of the database, you own the database, you are the operator, do you allow your developer to come and execute any type of queries, doing any kind of joins, or do some store procedure on your DB? No, you want to protect your database, because everybody knows if you let a developer in the database, it will start doing queries all over the place. And of course, it will be the fault of the database, not the data model, not the fault of developer. So, and once those two meet to each other, okay, they like to just shake their hands, but they just hate each other, to be honest. So this is where come these gateway or data gateway come into play. Okay, so you will create a gateway, a proxy on top of the database. In the same way as you are using API gateway on top of existing API, just to introduce technical features. So what are the technical features in this gateway? Well, we want to expose standard API. So we want to expose here a GraphQL API, REST API, working with JSON, gRPC, and introduce these loose coupling from the database to the way to interact with the database. So in the Cassandra world, it's a Cassandra node that we call Stargate without data. Okay, so these Stargate, so again, open source, stargate.io, is it's a proxy with API extension to be able to have multiple API expose, REST, GraphQL, and also document API. I will demo that to you. I told you that in Cassandra, you insert rows and tables. With this API, you can now interact with Cassandra using JSON, Cassandra query language, Pulsar, Kafka, gRPC, all incubating. And as a persistent layer, as of now, 3 versions of Cassandra. including the 4.0 that will be released pretty soon. I think it's only 10 bugs still open to finally release this long-waiting version. But there is nothing blocking you to implement another persistence API over here. So it's open source. It's called Stargate.io, and it's including in the Cassandra.io as a gateway to expose data as API. And now it's an API, and it's way easier to expose. Just HTTP call. You as a client are now stateless. You don't need to keep a connection open to the database. And you need to have connection open only to Stargate. You don't have to connect to every single node. This is the role of Stargate to do so. And Stargate is the proxy layer. It's the compute layer. And now you can make the compute scale and not the data scale. It's as cool as that. And so at Yelp, we did a meetup 3 weeks ago where they explained they just distribute 12 Stargate nodes just for the compute and keep with the existing data without the need to scale out just to add capacity throughput where the capacity has no changed. Okay, so pretty cool. Expose in a standard way, make the compute scale, so it's cheaper, and it's still open source. Okay, so to demo you these Stargate and API, I do have 3 ways, and I will give the slides to the team. So I think I will tweet about it and just give you. I can use Docker and Docker Compose. I can use Kubernetes, or I can use everything in the database as a service offering. And like that, I don't have to install anything, and it's pretty easy to show you. So I will use the last one. But if you're interested with Docker, here is a repo with Docker Compose, up-d, everything running. If you like Kubernetes, this is a repo where you install kind or Minikube on your machine, also GKE, AKS, it's explained, and you run that. And if you're interested in Kubernetes, we are running a 3 hours workshop at KubeCon Europe, and we will use exactly this code and this demo. So now you have it. And we will simply demo all the pieces of Cassandra. But today, we only focus on the data access, the Stargate. Okay, so I will simply use this because it's I don't have to install anything, and it's available as web. Okay. So what I will do, I will try to switch screen. Again, Vincent, tell me if you can still see my screen. Now I'm.
You're still good.
All right. Okay. All good. Okay. All good. All good. So this is, this is a repo, how to use Stargate. And the first things we need is create the DB. So I will go there and I will refresh just to be sure I'm logged in. And I will create a new DB. And I think the name is, so this service is free, okay? There is a free tier and you can do 40 million queries. Okay, what is the key space you like? Key space 1. So 40 million read and write per month, and you can go there. There is no credit card needed, and you can spawn Cassandra DB instance like that. So that's pretty cool for any demo and any small project you would like to try. Okay, so that guy will start, and so when an instance starts in this software as a service, it will start the full Cassandra stuff. So you will have monitoring, backup, restore, all handled for you, and of course, this Stargate. And so Stargate exposes multiple API. you can still have the SQL API, but more. So it took about 2 to 3 minutes to initialize. So it will go into pending and it will show up right after that. So, any question for now? Just checking the chat. And oh, you know what I should do in the chat? I should copy the link of the repo. That's always good to be able. And there is no need to install anything, so you can run that with me if you like more the hands-on. And I think I finally understood why sometimes I lost screen sharing. And it's all due to the view in Zoom anyway. Okay, so now the DB is active. First things you might expect, you go here to SQL Console, which is how to interact with Cassandra with the default language, which is Cassandra query language. And you want to execute queries to create objects. So you create tables and you insert data in your tables. Nothing special about that. That just create table, insert table. That gives you a first view of what the SQL, Cassandra query language look like, but nothing special, except maybe if you are already familiar with Cassandra, you may not know that you can insert JSON as is in Cassandra, as long as the structure you are using match the structure of the table. So here I'm using some scalar list sep map. And if I describe the table video, see the fields are UID, text, map, list, set. If the schema do not match, Cassandra will simply complain. So it's still not schemaless or anything like that. It's just a way to insert JSON in Cassandra. Okay, that's there, it's existing. So what's new here? Not much. Just simply put, even if we have Stargate on top of Cassandra, you can still interact with Cassandra as if there are nothing between you and Cassandra. So Cassandra query language is still there, obviously. But what else? Well, I told you about APIs. So first API available is the REST API. So let's see. In the Stargate, of course, Stargate provide the Swagger documentation. So with the Swagger UI, you can start interacting with the API. So what you need to interact with the API is a token, like an API key. So to have one, I'm going in organization settings, and I will go to token management. I will be database admin, and I will get a token. Your token has been generated. Yes, thank you for that. And I will go there, and I will copy my token. Maybe, geez. It's like, you know, the credential on AWS. If you lost them, you lost them. So let me copy paste properly there. I already have a token somewhere ready to go for the next part of the demo, but still, those are pretty secure. Yeah, and the last one is, the latest one is really the one that I need. Okay, so if I go to Swagger UI, now I can start executing some stuff. So working with the SQL API, I've created my token. So what's next? I can list the key space. Okay, so let's look for schema and say, oh, I want to list my key space, try out. You probably know Swagger, so there is nothing special about it. So here you can list the key space. All right, so far so good. You can create a new key space. You can add a table. So if I add my table in let's maybe key space, we stick to key space 1. So I will go here, trying to find my guy, add a table. Oh, let's see. I will add a table over here, try out, put my token. What's the name of my key space? It's still key space 1. What the body? I do have here the JSON. And so it's now a new way to interact with Cassandra with the REST API. Okay. But here, even if it's cool to use this API, it's still like the same as Cassandra query language. It's not. It's simply a new way to interact with the DB. It's cool because now, as a client, you are stateless and you can simply put a token, normal connection open, and you can scale the compute. That's pretty cool. But when it comes to pattern and query pattern, it's pretty close. I have created a table called user. If I want to insert data there, I will need my token. So let's see, add rows. Where is my guy? Add a column now. Add rows, which will be in the data. And I will key space v2 add row. I will go there, put my token, put my key space, and put my table name. It's users, and put some value here. It's in the here. So hopefully it will be happy with that, and I could insert stuff in my DB. And no field name columns. Yeah, probably just have a typo over here, but nothing special about that. So what I would like to show you now is part of the proxy. There is a document API. Now we are schemaless. Now we can insert any kind of document inside Cassandra. And to do so, we have implementing what I've called the document shredding, which is each time you create some collection, we will create a dedicated table in Cassandra, always the same. And we will do what we call shredding. So this is the JSON, and this is what it looks like when the JSON is splitted inside the tables. So each document will be stored on a single partition, the group by in the Cassandra world, and it will be read and write super fast. And you can also search by subpart of the JSON, which was not possible with Cassandra before. So now with the proxy, you do have some added value, and you can do some schemaless. Any object could be inserted in the document. So if I go here and execute simple things, so like creating a namespace. So let's see, this is my DB. Oh, this is where I am. This is where I will have my DB. Okay. Please show me my DB. Okay, here you are, and I will create a new guy. Namespace 1. All right, okay. The guy will just generate my. Did I click OK? Namespace 1. Should have clicked OK. Let me move that window. Yeah, I did. Simply, it took just a few seconds to show. Okay, it's there. And so if I want to list my namespace and try out, I still have my token. But what I would like to show you is I can create a connection, and then inside the connection, I can namespace ID. Oh yeah, there is no collection as of now. Okay, as of now, no data, but still the namespace is there. In a namespace, you will have collection. In a collection, you will have document. Exactly the same as Mongo or any document DB oriented, right? Okay, and I can go and on just to insert data, create any form of document, retrieve any form of document. It will be copy pasting stuff from here. Okay. Last but not least, part of the Stargate, you also have a GraphQL API, and not so famous yet in the Java world, but super used in the mobile and JavaScript world. GraphQL is the way to expose an API with auto discoverability. So that's pretty cool. And also you can shape your query exactly based on the response you would like to have. So GraphQL playground is embedded in the tool. And so now I can start interacting. And here I'm listing the key space. And if I do have the key space 1, it was one of my, I can also create read, update, delete, and provide exactly what expected. I'm looking at the time here, so I won't go into all steps of the demo, but there is no magic. I simply use all the mutation and queries. Queries are read-only, mutation are changing the data. So exposing the GraphQL API. Okay, so we are happy with that. We expose GraphQL, Document API, REST API, SQL API, soon gRPC, but we can do even more. What about you as a Java developer with all of that? Do you want to consume all the API and bring your REST-easy or REST templates if you are in the Spring world and try to read the doc and explain how to use the API? No, you don't. What you want is a nice SDK, like a template, and you can do all the steps using Java. And so in the same repo, there is this little project called Demo application. And that guy imports a library I've implemented, which is called the Astra Spring Boot Starter. And also I do have an Astra SDK. So the SDK will wrap all the code of the API. The Spring Boot Starter will initialize beans for the Spring Boot to know how to connect to the DB, and also wired with Spring Data Cassandra. I'm sure this is your main question. So yes, if you import the Spring Boot Starter, Astra, it will create the Cassandra session that will be understood, and you can work with the Spring Data and Spring Data Reactive. And here I do have the code just for you, what it looks like. I do have here 4 tests, which is exactly the same test as we did, but using the UI. So create the instance. So I'm using the client over here, and here so Fluent API, create a DB using the DevOps API. Then working with Cassandra language, how to create the type, how to insert, how to select. And again, the code is provided to you. Same with REST, how to use the REST API to list the key space, to create a key space, to create tables, to retrieve data and insert data. What you need is simply to go to the class demo dataset and change the token with your token. So REST API, Document API is all wired for you and ready to go. All right. And with that, I think I'm at the top of, yeah, I could, let's do, what? The token is, the token should be okay because the token is available in multiple DB. Let's create a DB named FreeDB2 and start instance with the unit test. Run as unit test and see how it goes. And on Astra, we should have a new DB. But again, it's just, okay, initializing. It will take a few minutes to initialize. And then we can go and execute, create table, create delete, all using the API and not through stateful connection. Okay, anyway, I can play the demo, but looking at the time, I simply want just to show a couple of resources in the end. So these demo, these hands-on, in my team, we are running them twice a week, live stream on YouTube. So on Wednesday, 12 VDT. So for you folks in the Atlanta region, maybe that fits the best. And also on Thursday, which is 12 IST, which is kind of midnight for you, so not great. And so we are live and we are waiting for people to do this kind of exercise with us, and use the tool. We also have a community, so the Fellowship of the Rings, so more than 10,000 people on the Discord. So if you have any question on Cassandra, Stargate, Cassandra, what's coming for Cassandra 4, or what is the new direction of data stacks and all open source, go there, ask your question. We are there for you. And I'm done with my slide.
Okay, you actually have some questions out there. So
Nice.
Juan asked, how are indexes created and handled?
Okay, so that's a very good question. So in Cassandra, you can create secondary indexes, and there are multiple flavors of secondary indexes. So regular indexes, SASI indexes, or SAI indexes, which is new flavor, again, open source and proposed to the Cassandra group. Well, so you can either use SQL to create the index. You can also go to the API and see that you do have some dedicated resources to create the index in the tables. So let's see, it will be, let me see, indexes. So here you are creating an index, and so you will provide the field that you want to get indexes. Because by default, when you query on Cassandra, you can only query on the primary key. And if you want to query on something else, you need to create an index. So index could be created at the REST API level, okay? If you are working with the document, I told you all the tables are the same. And so the indexes are created for you already. So create any document and you can start searching in the document, just providing the path or the subpath in a document, providing a where clause, and we will use pre-existing index for these generated document table.
Okay, another question popped in was how the data with timestamps are persisted when we move the database from one time zone, New York, to another time zone, California.
Okay, so each time you write a data on Cassandra, you do have a timestamp, and the timestamp is generated by the guy who accepts the request. So here it is. Okay, so let's see. Okay, so here the timestamp will be at what we call the coordinator level, and then the timestamp will be sent the same timestamp sent to the 3 replica. Okay, when you read the data, potentially you can have multiple versions of the data stored in Cassandra, and the last write always win, and we check the timestamps to do that. So now, what about nodes in multiple region? Well, the timestamp here is the epoch, and nodes of the same Cassandra cluster should be sync on clock with the NTP tools, solution like that.
Okay. And see, folks, you can also ask, you can unmute yourself and ask.
Sure.
And let's see.
Hi. This is related to the timestamp. Can you guys hear me?
I can hear you, yes.
Oh, thank you so much. So you mentioned epoch, right? The problem problem with the
Yes.
epoch, right, is based on the epoch time is based on the Unix machine timestamp, right? So then we may get, let's say the machine is running in Newark, you may get a different epoch. If the machine is running in Denver, you may get a different epoch.
Yeah, I got you. You're right. And this is why on a Cassandra deployment, you want to synchronize the clock of the nodes. So either using some dedicated tools like what we call NTP, which is a time server that other machine will rely on to set the time. But that's, yeah, you need to make sure that your machine does have the same clock.
As with any magical moment of Kubernetes clusters, right?
Yeah, but
Where
then
are
it's
they?
virtual, so the pod could be, you know, I don't know how the clock on the pod are handled, but because the control plane just spawned the pod, they should be in sync, I guess.
Should be, yes.
Should be, yeah.
All right. Has anyone else got any questions? One going once, going twice.
Sold.
Can you share the code? Like, is there any GitHub link is there for this code, demo code?
I didn't get the question.
I
sorry.
didn't understand that.
Is there any GitHub link is there for this shared code? Which you
Yeah, so, GitHub link. Yeah, sure. I have a lot of links for you folks. Okay, so let's go in the chat. So the demo is there. Okay, so let's go to the chat over here. Where are you guys? Here, chat. Okay, so the demo is here with all the pieces. And here I'm using the database as a service Astra. But if you want to work with Docker, I will share with you the link with Docker. So here, same call, same everything, except instead of Astra, the step-by-step is first install Docker, Docker Compose, just do Docker Compose -d, install. So this is the demo with your machine on Docker. Okay. Now, what about Kubernetes? It was my third QR code, if you remember well, on my machine. And for this one, you go over here and you go on workshop Cassandra. And this is step by step. You go to the wiki, and then it will explain you how to install the Helm repo to get Cassandra and spawn a Cassandra cluster in your Kubernetes. And I think there the instructions are defined for Kubernetes called kind, K-I-N-D, so which means Kubernetes in Docker, which is one way to run Kubernetes locally, which we would prefer against Minikube, just because with kind you can define what your Kubernetes cluster should look like. How much worker do you have? Whereas on Minikube, as far as I know, you do have a single worker. And when you are working with a distributed system, especially here, you need a worker per data node. Now, this is the reason why we put kind over here. That's working with GKE, AKS, EKS, no problem.
Thank you so much.
And I will put the slide in the same, okay? Because now the slide I show you are not in the repo, but I will put them in the same repo that I just shared.
Awesome. Okie dokie, folks. I think we are good. Cedric, thank you so much for presenting tonight. It was a fascinating topic. Thank you for staying up till, oh my goodness, about 2 a.m.
Yeah, 2:15, yeah.
So thank you for presenting. Thank you for staying up and giving this presentation. Folks, we look forward to seeing y'all in May.